So now we're going to apply those things that we've been talking about as far as reducing fractions and all of that kind of stuff. 16 over 28. Let me do the numbers, just dealing with the numbers for now. 16 over 28 is the same as what? 4 times 4? I guess you can kind of think of this as, you know what, instead of doing 4 times 4, why don't we do 4 is really 2 times 2, right? So this is 2 times 2 times 2 times 2. And then the 28, I can think of that as, well, it's 2 times, what is it, 13? 2 times 13? No, not 2 times 14. So I can multiply 2 times 7, because that's the same as 14. Let me just check. 2 times 2 is 4, times 7 is 28. All right, so this right here on the bottom is a secret code for 28. This right here on the top is a secret code for 16. Two sets of those 2's cancel out, so that one cancels out with that one, and that one cancels with that one, and you're left with 4 over 7. That's going to be that is going to be the numbers part, but let's talk about the x's. How many x's are on top? If I have x squared, I can think of that as x times x, whereas if I have x on the denominator, I can just think of that as one of the x's. Now, and something that's being multiplied on top will cancel out with something being multiplied on the bottom. So I can basically scratch those out. And so my answer is 4x, because that's all the stuff in the numerator, divided by 7. That is how I reduce that crazy looking monomial. Now over here I've got a rational expression, and it's 2x minus 6 over x minus 3. How can I factor this? How can I break this down? Just like I've been factoring this thing down into its primes, or basically dividing it until it can't divide anymore, I'm going to have to factor this down until I can't factor it anymore. In this case, I can pull out a 2, and so I've got 2 times x minus 3, and that's the same as the numerator. I didn't really change anything. Those are the same exact formula. Now in the denominator I have x minus 3, and so what I can kind of think of this as going about is basically this x minus 3 on the bottom will cancel out with that x minus 3 term on the top. So this is actually a secret code for 2. Even though it doesn't look like the number 2, it's really saying it's 2. Alright, let's try this one right here. 4x minus 12, and so I'm going to pull out a 4 out of the top because I can divide both sides by 4, and I've got x minus 3. If I were to distribute that 4 back in, I'll have 4x minus 12, which is the same thing. So I want to make sure that I'm not changing anything specifically. I'm just changing the way it looks. So what I'm going to do in the denominator over here first is I'm going to pull out a 2. And I end up with x squared minus x minus 6. Alright, let's do this. 4 is the same as 2 times 2. I'm going to break this down in its entirety. Now I can actually break this part right here, the x squared minus x minus 6, into, I can factor that using the old school factoring things that we did ad nauseum back last semester. So I have an x and an x, and what times what gives me negative 6, but when I add it together it will give me negative 1. I would say negative 3 and positive 2. If I multiply positive 2 and negative 3 out, I'll get negative 6, and if I add these two together, I'll get negative 1. If you multiply everything out as far as the denominator goes, you'll end up getting exactly what you started with, which is hopefully what you're going for. Now I can play the fun game of canceling things, and so this 2 will cancel out with that 2. I'm happy with that. The x minus 3 will cancel out with that x minus 3, and my answer is 2 over x plus 2. Now, there is a column here that I've been ignoring. It's called excluded values. There's excluded values in this answer. There are certain things that x is not allowed to be because there's domain problems. And when you're dealing with fractions, the only domain problems you have to worry about is zeros in the denominator. Now, over here, there are no zeros in the denominator for this answer over here. And then over here, there's also no zeros in the denominator because the denominator is 7. But over here, there is a possibility that the denominator could be 0. And that is, of course, if x is equal to negative 2. The way I can solve that is I say x plus 2, which is the denominator, cannot equal to 0, which, if I were to solve for that, x cannot equal to negative 2. So if you're asking me for some excluded values on this one, I would say negative 2 is your excluded value. Here's the answer. The excluded value on it is negative 2.